Sorry about that. Got caught off partway through this number 4 problem, but we're still in the same spot. We've shaded. I was just talking about how if you forgot to flip your sign, you're going to shade the wrong side. You're going to end up with the wrong answer. But we've got to finish this out by graphing our other line. This is where things are a little bit tricky. You have to remember your definition of horizontal and vertical lines. If you can't graph it in the calculator, it's going to be a vertical line. For example, if I go and try to graph this in the calculator, there's no way I can graph x anything because there's no x. This is just a y equals. We had to have y by itself, but this doesn't have a y at all. Okay? So there's no way to graph this line, and we learned the only thing you can't graph like that is a vertical line. Specifically, this is a vertical line at -2. So I hop over to -2, and I want a vertical line. This one's a solid line because it had the or equal to sign. Now I want to shade. This is another part that gets people a little bit confused. They say, but I don't know how to shade above or below this. Well, think about what this says. It says greater than or equal to -2. So I want everything greater than -2. Everything greater than -2. That means everything on that right side. If I plug a 0 in for x, it would be a true statement. But if I plug a -4 in for x, it would be a false statement. We don't shade false statements, okay? Now I'm trying to find that double shaded region. Well, right here is only shaded by the blue. Right here is only shaded by the black. This has no shading at all, and the only place that's double shaded is this big region in the bottom right corner, okay? So if I want a solution and a non-solution to this, anything down here in this region is going to be a solution. I pick something easy and something really far in there. That's at the point 1, 2, 3, 4, 5, 0. If I want a non-solution, I'm going to pick something really far away from this shaded area. Maybe something way up here in the very top corner. -5, 5. Anything not in this shaded region would work as a non-solution. Okay, but I wouldn't get too cute and try to pick something down here. It's kind of hard to see. Yeah, you could pick -3, -5, but if you're not careful with your graphing, maybe this line wasn't slanted the right way, just barely. I wouldn't pick anything really close to any of these lines. I pick something very clearly not a solution, okay? For number 5, we get into our first couple of word problems. This first key word is write the equation, so we know we've got equal signs in here, okay? Also, on 5 and 6, I've gone ahead and said what to name the variables. Later in the test, that's part of the question is having to name the variables. So if you later in the test don't remember how to name variables, you can look back at 5 and 6 for a little bit of help. The school that James is going to is selling tickets. On the first day, they sold 12 adult tickets, 6 child tickets for $120. Okay, so that's all one set of sales and one thing that gets grouped together. The school took 44 on the second day by selling 6 adult tickets and 1 child ticket. So there's one of the little things that they can do, especially in the USC, to trip you up, is they just put the same information in the second sentence, same sort of information, but they put it backwards, okay? So our first equation needs to be 12A, so 12 adult tickets plus 6 children's tickets, or 6C, that equaled $120. My second equation, I have 6 adult tickets plus 1 child's ticket, equaling $44. Okay, you don't necessarily have to have this one here. If you just put plus C, that would be okay. We know that's an understood one. And that's all you have to do. It just says write the equations. Okay, starting off slow with these. Write the system of inequalities for the following situation. Pablo's pickup truck can carry a maximum of 2,000 pounds, and he is loading his truck with 50-pound bags of cement and 80-pound bags of cement. He hopes to hold at least 20 bags of cement in his truck. Let X represent the number of 50-pound, Y represent the number of 80-pound, okay? So, 2 different things we're talking about. We're talking about the total weight he can carry. He's got to be less than that, like an elevator. But we also want to carry at least 20 bags in total. So maybe he just wants to get at least that many bags in his truck. You don't want to make a trip if he's not going to have at least 20 bags. So when we're talking about the weight, we have a 50-pound bag, which is lettered X. So every single, no matter how many 50-pound bags we have, it's going to always be 50 pounds per bag. If we have one bag, this is only 50 total pounds. If we have 10 of these, you've got 500 pounds. We're adding to that however many 80-pound bags we have. And we need that to be less than or equal to our maximum weight. Can't go over that maximum weight. Okay? So that's our actual weight inequality. Okay? Our other inequality just deals with the fact that we want at least 20 bags. Doesn't matter what kind of bag specifically, it matters how many bags total. When it comes to what type of bag matters, that comes from this equation. Because yeah, if you want at least 20 bags, you can load your entire truck down with 40 or 50 80-pound bags, but then you're going to weigh too much. We just need at least 20 bags. That means X plus Y, all of our bags combined, has to be greater than or equal to 20. That second inequality says, I don't care what kind of bag I'm bringing, I want to bring at least 20 of them. Okay, kind of like the theater problem where we had adults and children filling up the seats. Number 7, determine whether 6, 0 is a solution to the following system. Show all your work to receive credit. If it's a solution, it's going to always produce true statements when we plug it in. This is an X value and a Y value. So if I'm looking at this very first equation, I've got Y equals 2/3 X minus 4. Well, I'm plugging in a 6 for X and I'm plugging in a 0 for Y. So that became a 0. We plug in a 6 for X. 6 times 2/3 is going to give me a 4 minus 4. And then I get 0 equals 0. That's a true statement. So it worked for the first equation, but you have to test both. That just tells me that this point is in this line somewhere. It does not tell me that it is where these two lines cross. We have to check both equations. So when I go to check this second equation, I'm going to plug a 6 in for X. And I'm going to plug a 0 in for Y. So here was one equation on the right. Here's another equation here on the left. I plug in my given test point. I get 12 plus 0 equals 12, which is just 12 equals 12. So it worked for the second one as well. Worked for the second one. Moving on to number 8, we have these inequalities this time, but it's still X and Y. Our first one, we plug in, we had Y is less than 2X plus 1. We plug in a 5 for Y, and we plug in a 2 for X. And then we evaluate our statement. Okay? 5 is less than 5. This is where it's tricky because a lot of people look and go, oh yeah, because on the last one when they were equal to it worked. But these are inequalities, and specifically this is just a less than inequality. 5 is not less than 5. So this is wrong. These problems say show all work to receive your full credit. If you wanted to stop here and you were really sure about your answer, you could. But this is also a partial credit test. So just in case you got that one wrong, you might want to work out the second equation just to get a little bit of extra credit in case you got it wrong. If you got this right and you know you got it right, you know you can stop here because it has to be a solution to both inequalities for it to be a solution to our system. But you might want to do a little bit of extra work, just kind of, pad the stats a little bit. In case you got that first one wrong, you'll get that second one, get a little bit of partial credit there.